Hello dear learners, when you are attending a maths lesson with me, get ready with your book, pen and your calculator. Today we are going to see the chapter Calculus. I have already taken a question from a question paper. This is the first part of the calculus question in the examination. So as you can see in this question, you have the first part of the question to find the derivative from first principles, and then the remaining questions are also to find the derivative but using the rules of differentiation. So today we are going to see how to use the first principles and also the rules of differentiation. Okay, first principles, we have to use the formula from the formula sheet, which is derivative of fx, that is f prime x equal to limit h tends to 0 fx plus h minus fx over h. That is the first principles formula. So we use this formula only if the question is asking you to use the first principles. So this part alone is called average gradient, but when you include the limit, that means when h becomes 0, it becomes a gradient at one point. That is called a derivative of a function. Now let's take an example of f of x as 3x square plus x. Now we are going to find the derivative using this formula. So when you use this formula, it's always easy if you find fx plus h first. Then you just have to substitute it in the formula. So fx plus f, if fx is 3x squared plus x, fx plus h simply means you change all the x parts. This is x square and another x. All the x is going to be replaced by x plus h. That's called fx plus h. So let us find the fx plus h here. So 3, then x is going to be replaced by x plus h. So square plus x plus h. That is fx plus h. Now simplify the fx plus h. Don't forget to leave the 3 as it is. Then now you take the square of x plus h, which is x square plus 2xh plus h square plus x plus h, which will be, now you open the bracket, multiply by 3. This will give you 3x square plus 6xh plus 3h square plus x plus h. Now you can see that there are no like terms, so you cannot simplify further. So that's the fx plus h. Now we are going to substitute this in the above formula, which is f prime x equal to limit h tends to 0 fx plus h, which is 3x square plus 6xh plus 3h square plus x plus h minus fx. Don't forget to put the bracket there. 3x square plus x, that was our fx, the whole divided by h. Okay, which is equal to, so we are just opening the bracket now, limit h tends to 0 3x square plus 6xh plus 3h square plus x plus h minus 3x square minus x, the whole divided by h. Now you can see that the 3x square and minus 3x square is 0. x and minus x 0. So they cancel each other. So what is remaining now is 6xh plus 3h square plus h, only 3 terms that are remaining. Now the important step comes where you take the h as a common factor. Don't worry about any other common factor. We are only interested in the h here as the common factor. So even if there are other common factors, we leave it alone. Only take the h out so that you can cancel the h, that h with the denominator h, because we can't have a denominator h when you apply the limit. H is becoming 0, so denominator cannot be 0. That's why we have to cancel the denominator h out. Now from what is remaining, okay, let me write one more step to show you. What's remaining here is 6x plus 3h plus 1. Now we are going to apply the limit. Applying the limit means giving h the value 0. So if you give h equal to 0 here, you are getting the final answer will be 6x plus 1. That's the final answer. That is the derivative of 3x square plus x. Okay, that was, I was doing this question to show you how to use the first principles. Okay, here the exam question is determine f prime x from the first principles. So we know first step is to write the formula f prime x equal to limit h tends to 0 fx plus h minus f of x over x. You write the formula correctly from your formula sheet. Now, as I told you, it's always better to find the fx plus h first. So fx plus h in this case is very easy. Only x is there to replace by x plus h. So it's 3 over x becomes 3 over x plus h. Okay, let's go back to the steps now. So here now we are going to say limit h tends to 0 3 over x plus h minus fx was 3 over x, the whole divided by h. Limit h tends to 0, simplification. Now in the numerator you have two fractions. So remember this step, whenever you have two fractions like a over b plus o minus c over d, if there are no common factors in the denominator, BD will be the LCD. Then on top you are going to have AD plus O minus BC, BC and AD. So you must remember this step. That's a basic step in fractions. So here also we don't have any common factor in the denominator. So the product will be the LCD, that is x times x plus h. That will be the LCD. So on top you are going to have 3x minus 3 times x plus h, the whole divided by h. Let me write it like this because already there are a lot of fractions now. So let me write the h in that way. Now again, limit h tends to 0. Simplification here, opening the bracket, 3x minus 3x minus 3h divided by x times x plus h multiplied by 1 over h. You change the division to multiplication by multiplying by the reciprocal. Okay, so 3x minus 3x 0. So what's remaining on top now is 3h over x times x plus h multiplied by 1 over h. This h and this h cancels. Okay, if you want me to cancel here, That was the cancellation there. Here in numerator and denominator, h divided by h becomes 1. So what's remaining? Let me write what is remaining after all the cancellations. What's remaining is -3 on top and x times x plus h in the bottom. Now you can apply the limit. Applying the limit means h becomes 0. So when h is 0, what's remaining is the answer now. That is -3 over x times x, that is x square. That is the final answer. Okay, so you must take the notes on this one, because this is always asked in the examination. Fractions. We are going to the second part of the question now. Before we go to the question, let me quickly explain how do we use the rules of differentiation. Okay, there is only one main rule, which is d over d, that is derivative with respect to x of let me say k times x to the power n is equal to k will remain as k, n x to the power n minus 1. That is a rule of differentiation. So the k represents a constant, k will remain as k, then the x to the power n, the power becomes n x to the power n minus 1. For example, d over dx of 10 x to the power 4 will be 10 will remain as 10, 4 x to the power 3, 1 less, n minus 1, 1 less than the power, so it's 3. So which will be 40x cube. That is the rule. So to make it easier, you can also do like this. If you have d over dx of let me say 5 over 2 x cube. So what we are actually doing is, you take this coefficient, which is 5 over 2, the constant there, multiply by the power, then the power will be 1 less 2. This is happening. So here the final answer will be 15 over 2x square. That is the answer. So that's how we use the rule. Now when mentioning the rule, let me also mention, if you only have a x there, no other constant, no other power, then the answer is 1. But if you only have a constant there, like let me say 10 only, then the derivative will be 0. Derivative of a constant is 0. Derivative of x alone is 1. Okay, these are the special cases. Okay, now, okay, we are going to the second question now. Determine dy over dx if y equal to pi cube x minus cube root of x. Okay, before I go to this question, let me also mention the roots. If you have any, let's say for example, cube root of x, like in this question, you must change this to x to the power 1 over 3 in exponential form before you differentiate, because the rule that you know in differentiation is d over dx of x to the power n is n x to the power n minus 1. So whatever you have in the question must be, you must change it in this form, x to the power n. So here it is not in that form, so change it into exponential form. Here also you have a denominator, you cannot have it, because we only learned one rule, which is x to the power n is in n x to the power n minus 1. So here also you have to change it into all the question, whatever is asked, you change it in the form k times x to the power n before you differentiate. Okay, so let me remind you about the other exponential, root form. If you have cube root of x square, it can be written in a root exponential form as x to the power 2 over 3. Okay, coming back to this first part. So here y equal to pi cube x minus x to the power 1 over 3, changing to exponential form. Now this is ready to differentiate. So when it is ready, you write dy over dx. When it's y, the derivative is dy over dx. Pi cube is the constant here. Derivative of x is 1. Here the n, which is 1 over 3, x to the power n minus 1. So the answer will be pi cube minus 1 over 3 x to the power negative 2 over 3 when you subtract negative 2. This is a final answer. That's all. That's a final answer. Now let's do the second question also here. Y equal to. So when you have a fraction, if it's a monomial, you divide each term by the monomial. Over 4x minus 3x over 4x, which will give you 7 over 4 is the constant there. X to the power 5 divided by x is x to the power 4 minus 3 over 4 is the constant here. X divided by x is 1. Now it's ready to differentiate. So the derivative dy over dx is equal to 7 over 4 times 4 x to the power 4 minus 1, 3 minus the derivative of the constant is 0, which is equal to 7x cube. That is the answer. Okay, so altogether this question had 10 marks. Okay, that is a basics in calculus. Now in the next lesson we are going to see how to draw the cubic graph. Hope you understand. If you have any questions, write your questions in the comment box, and if you understand, like the video, share and subscribe. Thank you very much.